Hello everyone, welcome to today's class. This is Teacher Simon taking you through A-level mathematics, pure mathematics 9709 stroke 31 for May, June 2025. And this is part 2. Question 7 is coming from trigonometry part A. Express 5 sine of x plus pi over 6 minus 4 cos of x in the form r sine of x minus alpha, where r is greater than 0 and alpha is ranging from 0 to pi over 2. That is in the first quadrant. State the exact value of r and give the value of alpha correct to 3 decimal places. The first thing we shall do is to expand this one using the compound angle formula. So we have 5, then sine of x, then plus pi over 6, then minus 4 cosine of x. Now this one is going to be 5, then we get sine x cosine of pi over 6, and then plus, then cos x, then sine pi over 6, then minus 4 cosine of x. Okay, then after this we can now simplify the ones that can be done. So this one here is root 3 over 2. So we shall have 5 root 3 over 2 of sine x. Then this one is a half. So we shall have 5 over 2, then cosine of x minus 4 cosine of x. Now these two can be simplified, not so? All right. So 2 times 4, that is 8. Now 5 minus 8, that one gives us a minus 3. So meaning we have 5 root of 3 over 2, then sine of x, and then we shall have a negative 3 over 2. Okay, because 5 minus 8, you get what? A negative 3 cosine of x. Okay, now this one here, I've always told you, you don't need to waste time by expanding these. Then you equate the coefficients. All you need to do is to get the coefficient of sine of x here, which is 5 root of 3 over 2. You square it, then plus, this is minus 3 over 2, the coefficient of cosine. Okay, you also square it, then under the square root. This one will give us the value of r. Then you write sine here, and then we shall have x, then minus alpha is going to be the arctan. This is the arctan of, because here I'm seeing sine, then the coefficient of sine is the one that is going to be in the denominator. So over 5 root of 3 over 2. Okay, then this other one is the one that is going to come here. Okay, you don't write here as a negative because you see here as a negative. It is already catered for by the sign that is in there. Okay, in my chapter summaries, I can actually show you that. Okay, very fast here for trigonometry. I want you to see what is happening here. For sine, okay, here, whether plus or minus in here, that is what we are going to have here. But then we have r is going to be the square of a, and it is the square root of a squared, then plus the b squared. Then tan of alpha is equal to b over a. I want you to look at the coefficient of a here. Okay, it is the one that is down here. I mean the coefficient of sine, it is the one that is here. And then the one of cosine, when it comes to this, is the one that is up here. It is the same thing that they actually show here when it comes to the cosine. So the one of the cosine, of course, when you expand cosine of, let's say, a plus b, this one is going to give you cos a, cos b, then minus. So if it is a plus, then you are having here a minus. So that's why they're saying plus, then you go with a minus here. If you're having a minus here, then you go with a plus here. You see that? Then What else do we have? Of course, I didn't continue with the sine whatever, okay? Sine A, sine B. But now I want you to see also here, it is the same alpha here. So the coefficient of cosine here is the one that is down here. If you are expressing it in terms of cosine, that is the same thing that I've done here, that I'm expressing it in terms of sine. So the coefficient of sine is the one that I'm going to put here, as simple as that. But if you have time, you can expand. Okay, you expand this one and then you equate the coefficients of sine x, and then also this one, then you solve accordingly. You will still come back to this. Okay, so what do we get here? This will be 25, then times 3 over 4, and then plus this will be 9 over 4. So 75, then plus 9. Isn't that 84? Then when we divide by 4, that is a 21. So meaning that what we are having here is going to be square root of 21. Then sine of x, then minus, let's get the arctan of this. And since they gave us this one here, that means the calculator has to be in radians. Okay? Very important. Yeah, you will excuse me, my calculator here is very, very small. It might be too small for your eyes, but you can see on the pop-up display that it is in degrees, so we have to change it to radians. So I'll press then shift, then mode, and then radians is option 4. So we shall have then shift tan, that will give us the arctan, and then 3 over 2. 3 over 2 is the same as 1.5. Then down here we have 5 over 2 is 2.5. Then root of 3. And then the answer here gives us 0.333 to 3 decimal places. And remember here they said alpha has to be to 3 decimal places. So if you write to any other accuracy, then you will be crossed. So this is 0.333. Okay, as simple as that. So this is our answer. Part B, hence solve the equation, this one here, which is equal to root of 7 for theta ranging from 0 to pi, then give your answers correct to 2 decimal places. Now, by referring to what we are having here, okay, look at this 2 theta, okay, and you also look at this x here. We shall therefore say that this one here will be, remember, we have expressed this one in terms of sine, which is root of 21, then sine of, it was x, then minus, then the alpha. Now we are going to put 2 theta, then minus 0.333. Okay, then this one will be equal to this root of 7. You see that? Let me in fact put this one here, and we say comparing with what are we having here? 5 sine of x, then plus pi over 6 minus 4 cos of x, okay, which is root of 21 sine of x minus 0.333. Therefore, I can say that x then is equal to 2 theta. Okay, now where there is x, I put 2 theta, as simple as that. Now let's continue. So from here, 2 theta minus 0.333 shall be equivalent to root of 7. Then we divide. It will be the arcsine of root of 7. We divide by root of what? 21. Okay. So arcsine of that, what will it give us? Remember, our calculator has to be in radians. So we have the arcsine of root of 7 out of root of 21. That is 0.615. I can say 0.615. Now, I'm going to maintain the decimal places here. Let them be 3, since this one is in 3, okay? Now, this one is a positive figure, and sign is positive in the first and second quadrant, not so? So I need to get the next answer in the second quadrant, right? Which is going to be pi, which is 180, then minus the acute angle. So 0.615. You see that? So meaning that now our theta from here is going to be 0.615. Then you add 0.333. Then you divide it by 2. And then this pi minus 0.615, you'll add a 0.333. Then we divide by 2. What do we get here and then here? 0.615 plus 0.333. Then we divide by 2. That one gives us 0.474. 0.474. Then the next one, it is pi, then minus 0.615, then plus the 0.333 over 2. And this one gives us 1.4297 whatever, which I can write as 1 point, maybe forward, 30 whatever. Okay, so implying that our answers are going to be, remember they say to 2 decimal places, so theta is going to be 0.47 and then 1.43. Okay, 2 decimal places. These ones are in radians. And by the way, we are not exceeding. This pi over 3 is 3.14, and these ones are below that. Okay, so that is what we are supposed to have there. Question 8 is coming from vectors. With respect to the origin O, the points A and B have position vectors 2i plus 4k, and then 5i plus j plus 6k respectively. The line L1 passes through the points A and B. Find the vector equation of the line L1. I always draw this when it comes to equations of lines. Okay, let's say this is the main road and this is your home, your origin. Okay, and maybe this is where you join the road from here. Okay, that is at point A. Then there is a shop, maybe you bypass, which you know very well, and let's say that is at point B, and this distance you know it, and then you are going somewhere. So any distance you are going to be traveling, okay, beyond this point here, beyond point B, okay, is going to be a certain scalar times this distance here. Okay, so our r, which we always put, that point which we don't know you will pass through, is a certain distance whose value is going to be, let's say that from the road here to that point there, it is going to be a certain scalar times this distance which is known. You get it? So we have, this one is OA, then OB, then OR. So we need to get this OR here. Okay, but first we are given OA, which is 2 0, and then 4, because there is no j in here, okay? And then OB is given as 5, then 1, then 6. When you write them as column vectors, you don't bring back the i's, you just write the coefficients of these I, j, and k, okay? All right, now from here, we shall need to get, by the way, this one here. So this rod is going this other side, okay? That is its direction. So we need that AB. AB is equal to AO, then no. A to B is equal to AO, then plus OB. But this AO is the negative of OA. You see that? And then this one is the positive one because it is going in the same direction. So what you do, without wasting time, you get the last minus the first. So AB is equal to, the last is B, the first is A. So I will say OB minus OA. So my OB is 516, then subtract OA is 204. Now 5 minus 2, that will give us a 3, then a 1 in the middle, and then a 2 there. So I need to get O to R. O to R is going to be OA, then plus AR. Are we there? But this distance, like I said before, AR is something times the AB, which you know. So OA, then plus lambda of AB. The scale I'm using here is lambda. We usually use lambda, then other times we use what? There is S, there is T, there is mu, like that, okay? These are actually parallel. AR and AB are parallel. So for parallel vectors, these are the ones which can be expressed in as scalar multiples of each other, okay? So AR is a scalar multiple of the AB. You see that? All right, so that means we are going to have our R here. This is R here, maybe that is B, and maybe that is A. So our OA is 204, then plus lambda. Our AB is 312. So this is going to be our equation of the line L1. They are saying the line L2 has this equation here. Show that L1 and L2 do not intersect. So first of all, I will say if these ones are to intersect, okay, for intersection, then they should be having the same x coordinate, y coordinate, and the z coordinate. So I will equate the parametric equations, okay? So for L1, we shall have 2, then plus 3 lambda, then 0 plus lambda, then 4 plus 2 lambda, okay? So in the middle, we are having lambda, and then here it is 4 plus 2 lambda, okay? These ones here will be equal to, now have the x coordinate here is going to be, look at the I. Here we have a 2, and then the I here. So mu times 1, that's a mu. And then 1 here, and then 2 mu. 1, then 2 mu. And then 5, then 3 mu. 5, then 3 mu. So that is that, okay? Now, what we are going to do, we look at this one, equation 1 and equation maybe 2. We solve them simultaneously. We get the values of lambda and mu. And then after that, we test with this third equation. You test with the equation you have not used, because you can use the second equation and the third equation. You solve those, then you test with the first one. You see that? You can use the first equation and the third equation. And then after, you test with the second. So it is up to you. You get it? So this is equation 3. Now, solving, which one? Solving 1 actually. 1 and 2. Using 1, you can actually see that these 2 can go. You see that? So meaning we can have 3 lambda, which is equal to mu, right? In fact, let me say here that from equation 1, then this one is equal to that. And then after that, what else are we going to do? We shall go to, let's say, equation 2, okay? Now we can substitute into equation 2. So lambda is equal to 1 plus 2 mu. So lambda here is going to be 1 plus 2. Mu is 3 lambda, not so? All right, now put lambda on one side. So bring this one here. First of all, that is a 6, okay? 1 minus 6, that will be minus 5, which is equal to what? 1. So meaning lambda is equal to negative 1 over what? 5. If lambda is equal to negative 1 over 5, this simply implies that mu, which is 3 times this one, is going to be 3 over what? 5. Not so? Then from there, we are supposed to test. I've used equation 1 and equation 2, so I can say testing the values of lambda and mu with equation 3. You see that? Now, we have 4 plus 2 lambda. If the value we get here is the same as the one we get here after substitution, that means the 2 lines intersect. Actually, they can't give you such a question that prove that L1 and L2 intersect. If the 2 intersect, they always ask for that, for the position vector of the point of intersection. You see that? So this one is equal to 5, then plus 3 mu. So we have 4 here, then plus 2 times negative 1 over 5. Is it equal to 5, then plus 3 times negative 3 over 5? 5 times 4, that is 20, minus 2, that is 18 over 5. Is it the same as what we are getting here? 5 times 5, that is 25. 25 minus 9, that is a 16. So 16 over 5, so it is not. Therefore, L1 and L2 do not intersect, because the third equation is not satisfied. Okay? Part C, find the acute angle between the directions of L1 and L2. The directional vector of L1, I will let it to be D1. That is the AB we got. Okay? If you check back here, the AB we got, the directional vector, the one we put in brackets here, that is 3, 1, 2. And then D2 is the directional vector of L2. That one is the one inside here, which is going to be 1, 2, 3. 1, 2, 3. So using the scalar product, it is actually given in the list of family. So we have D1 dotted with D2, then this one will be equal to the magnitude of D1, then times the magnitude of D2, then cosine of the angle that is in between them. You see that? All right. Now from there, what do we do? How we multiply these two here. But then for us to get the theta, it is going to be the arc cos of d1 here, then times the d2, I mean the dot product, then we divide by the modulus of d1, then times the modulus of d2, just like that. Okay, so what do we have? The arc cos of 3 times 1, this one times this, then 1 times 2, and then 2 times 3. Okay, so plus 1 times 2, then plus 2 times 3. Then we divide by the square root of, this is the modulus of d1, that is 3 squared, then plus 1 squared, then plus 2 squared, times root of, this is 1 squared plus 2 squared, then plus 3 squared. Okay, so what are we going to have here? Let us simplify this one. This is 6 plus 2, 8, then plus 3, that is 11. So that is 11, then out of, this one is 4, then 5 plus 9, that will be a 14. Even here we have 9, 13, 14. So root of 14 times root of 14, that one gives us a 14. So I'll just write here 14. Then putting this one in the calculator, what do we get? Your answer can be in degrees or radians. Shift and then cosine, then we have 11 out of 14. In degrees, that is 38.2. That is to 1 decimal place. Or if you are to put it in radians, I just press shift then mod for that. Now it is in radians, so when I press equals, that will be 0.667. 0.667. This is radians and it is to 3 significant figures. You just give one answer. Question 14. The constant a is such that when you integrate from 1 to 6, this function here, 6x natural log of x dx is equal to 4. It is equal to 4. Part A, show that a is an exponent of 1 over 6, then into 5 over a squared, then plus 3, where the exponent of x here denotes e to the power of x. Okay, now what we are having here is a product of two functions. And I've already said, where you have a product of two functions, here we are going to integrate using what we call, it is integration by parts. So in order, one function is differentiated, the other function is integrated. But in order to know which one is differentiated and which one is integrated, you just do this. You use this acronym, ILET. Okay? ILET. Now, I here means inverse, trigonometric functions. Then L here means logarithmic functions. Then A here is algebraic functions. Then T here is trigonometric. There's a difference between inverse trigonometric and trigonometric. Inverse trigonometric functions. And then we have E here. Which one do you think it is? Exponential functions. Exponential functions. Okay, now the one that comes before the other is the one that is differentiated. Then the other is what? Integrated. When we look at this is what? Algebraic. Okay, and then this is logarithmic. So algebraic comes after logarithmic. So we shall look at this one first. So we shall differentiate this, and then this one you integrate. Okay, so what are we therefore going to have? Our u is going to be that natural log of x, and when you differentiate this one, you know, when it comes to differentiating a function, natural log of a function, we get that function, we differentiate it, then we divide by that function. You see? Uh-huh. So that is what we are supposed to have there. The function is now x. When you differentiate it, you get a 1. Then divide by that function. You see that? Uh-huh. Then we are going to now integrate. So dv dx is the one that is equal to 6x. And then the v will be the integral of this 6x. Okay? With respect to x. So this one will be 6x squared over 2. That will be 3x what? Squared. I don't need to put this plus c. Okay? I'll not need it in the what? In the computation. So using integration of u, then dv dx, even this one is stated in the list of formulae, okay, which is equal to uv, then minus the integral of v, then du dx with respect to x. Now we are going to substitute here. So when we integrate from 1 to 6, to a of 6x, then the natural log of x dx, we shall have our u is natural log of x, then times v, which is here. So I'll write 3x squared first, okay, so that I don't interfere with this one, because usually many students can confuse this one, and then somebody ends up with 3x cubed, yet this one is a different function from this, okay? So it's better you write the natural logarithms of functions last. Okay, then what else do we have? We have that, then minus the integral of what is our v? It is 3x squared, then times du dx is 1 over x. 1 over x, then with respect to what? To x. I'm going to put the limits of the integration are a, and then 1. But then this one, they said it is equal to what? To 4. So we have 3x squared, natural log of x, then minus the integral. This one is going to be reduced to 3 of x, then with respect to x, okay? And then from here, we have 3x squared, natural log of x, then minus, increase the power by 1, divide by the new power, so that will be 3x squared out of 2. Then we can put the limits, okay? So when I put the limits wherever there is x, then I can put the a, so that will be 3a squared, then natural log of a minus 3a squared out of 2. Then after that, we can subtract, put a 1, so that will be 3, natural log of 1, which is a 0, then minus 3 over 2, right? Then this one is equal to 4. Now, this one is 3a squared, natural log of a minus 3a squared over 2. Then, of course, this one is a 0, so this one will be affected. It becomes a positive. So plus 3 over 2 is equal to 4. You see? And now from there, we are going to, now by looking at what we are having here, exponent. Now in here, we are going to make a the subject of the formula. It is either this one, or this one. You get it? So, and since here we can see that an a is still expressed in terms of a, you cannot solve such equations using the usual algebraic methods. So you can solve them using numerical methods. So this question is coming from numerical methods. But since we are having e power something, that means it is this a which was made the subject, because to undo the natural log, then we use exponential functions. we use exponentials, right? So let's make this one the subject of the formula. So we have 3 of a squared, then natural log of a. This one will be equal to 4 minus the 3 over 2, then plus 3a squared over 2. Okay, then natural log of a is going to be equal to, we shall divide all through by what? 3a squared, not so? This is 8, then minus 3, that will be a 5. So we have 5 over 2, then plus 3 over 2 of a squared. Then this one here will be divided by 3a squared. Okay? And from there, we can actually see that, of course, now, you remember log of a, b is equal to c. This natural log of a is the same as log base e, then a. So we shall say a power c is equal to b. Therefore, e, then power the whole of this, then is equal to the a that is here, right? Good. So we shall have our a here, which is equivalent to e, then to the power of the whole of this. Now, this 2 here will multiply with the 3 here, because we are going to have, let me write it like this here, 5 plus 3a squared over 2, then times the reciprocal of this one. That is how it is. So that is how this one multiplies with that, okay? Then, next, I can pull out the 6. So when I pull out the 6, I will have 1 over 6 into, okay? This is 5 plus 3a squared out of a squared. You see that? Now, that means everything in here, the 5 is over a squared. The 3a squared is over a squared. That means I can have here 1 over 6, then into 5 over a squared, then plus the 3. So that will be my a, as simple as that. I think that is what they told us to prove here. Yes, that is it. When you check this one here. So this one is supposed to be e, then to the power of 1 over 6, and the rest of whatever is here. You see that? Part B, verified by calculation that a lies between 2 and 2.1. If, for example, I have a graph, and maybe these are my axes, and this graph, let's say, cuts x-axis here. If it cuts x-axis here, let's say this is the root, then there is a value of x that is to the right of the root, and then there is also a value that is to the left of the root. Are we there? Now, if this is x1 and maybe this is x2, the value of x1, when we substitute in the function based on what I have drawn here, this one is going to meet, it's going to give a value of y, let's say here, which is positive. Are we there? Because it is above what? The x-axis. Then the value of x here is going to give a y value that is actually what? A negative. Do you see that? So that means when we get these two values, if the root is in between them, when we get these two values and we substitute them in the equation of the function, okay, then we should be in position to see two different signs. One gives a negative, the other one gives a positive. You get that? So we need to get a function from what we are given, okay? So first of all, we have a, which is equal to e, then to the power of 1 over 6 into, I think it was 5 over a squared, then plus 3. Okay, so bring everything onto one side, and then you form an equation. I can bring this one this side. Okay, so that means if I just duplicate this and I put it here, then I make sure that here I put a minus, then that means this one will be equal to 0. You see? So now this one will be a function in terms of a. So a, then minus the function here is going to be the whole of this. You see that? Now we substitute what is f of 2. So we shall substitute a 2 wherever there is what? An a. So this is 5, then over 2 squared, then plus 3. It will give us a certain value. Then even f of 2.1, wherever there is a, we put a 2.1. It will also give us, oh, there is something I missed here. This one is supposed to be 1 over 6, and this whole thing here is supposed to multiply that. I think it is better that way. So 1 over 6, then into 5 over 2.1 squared, then plus 3. Then this one will give us a certain value. So let's put in the calculator and then we see what we get. 2 minus, then we need e to the power of, then we have 1 over 6, then multiplying 5, then out of, this is 2 squared, then plus 3. Close the brackets. So this one will give us a negative. So it's a negative 0.0306, negative 0.0306, and the rest of the values. Okay, then how about this one here? So I'll come to this one, and wherever there is a 2, I'll put a 2.1. So 0.1, then also come back to this one here, put a 0.1. And you can see that this one is a positive. You see that? So I'll write 0.1083. So one is positive, the other one is negative. Don't just stop there. You conclude and you say, since there is a change in the sign, since there is change of signs for f of 2 and f of 2.1, okay, then a, which actually becomes the root, then a lies between 2 and 2.1. You just write this statement. Then we go to part C. We are supposed to find that a. They are saying use an iterative formula based on the equation in part A to determine a correct to 2 decimal places. Give the result of each iteration to 4 decimal places. Now, since we don't know the root, but it is in between 2 and 2.1, then we use an average as our initial approximation. So I'll let the initial approximation, be, let's say, x1, which is going to be 2 plus 2.1 over 2, which is going to be 2.105. It doesn't matter which one you want to begin with. You can even say your initial approximation is that one, your initial approximation can be that one. But if the root is in between those two values, this is 2 and then the 2.5, let's say the root is here, then the one which is in the middle is nearer to the root. Okay, so it saves your time. Okay, then what else do we have? So let's get our x2. So x2 is now going to be equal to, I'll just show the examiner that I've substituted in here, but you don't need to show each and every step. Okay, so our a here, the first one is 2.05. It has to be squared, then plus the 3. Okay, all right. Let me shift this one a little bit down. The others are powers. So what do we get here? We have e, then to the power of 1 over 6, and then this is 5 out of 2.05, then squared, and then plus 3. So what do we get? 2.01. okay, to 4 decimal places, that would be 0103. 2.0103 for decimal places. Now you put this where this one is. Okay, so you just write x3, which is going to be, you don't need to show this again. Okay, just write the values. So I'll come to this, and where there is the 2.05, then I'll put 2.0103. You put the 1 to 4 decimal places, don't put answer. The answer you have gotten. So you come here where there is 2.05, then you put the answer I got. No, you might, that might fail. So you substitute the ones of the 4 decimal places that you're doing. So this is 2.02, then 663. Okay, then x4, 0263, 0263. Then we have 0197, 0197. Then x5, 0197. So I will come to this one here, 0197. That is 0224, 0224. Since we are going to get our answer to 2 decimal places, this one will give us 2.03. This one is 2.02. 2 decimal places, okay? This one is 2.02. Now, since we have gotten these two, x4 and then x5, and they are giving us the same value, 2.02, so these are the minimum number of iterations we are doing. Are we there? Then we do one more to confirm the value, okay? We do one more to confirm. So x6 here is going to be 0224. 224. This one gives us 0213. 2.0213. You see that? Now, here we can see that to 2 decimal places, all of these 3, okay, are giving us, they have to be 3 values, 3 iterations that are giving to the same, that are giving an answer to the same decimal places. So this is 2.02. So I will therefore conclude that what are we finding based on this equation to determine A. So you will just say that A is equal to 2.02. Okay, therefore A is equal to that, and these are 2 decimal places. As simple as that. Question 10 part A is coming from polynomials. Find the quotient and the remainder when x power 3 plus 5x squared minus 2x minus 15 is divided by x squared minus 3. So I'm going to use long division here. Okay, so we have our dividend here is x cubed, then plus 5x squared minus 2x minus 15, and then the divisor is x squared minus 3. You divide the first with the first, the rest you multiply. So this divide by this, you get x. Then multiply. Are we there? So we shall get x cubed, then minus 3x. When we subtract, this one disappears. Then since there is no x squared in here, then we shall remain with that 5x squared. Now there is this one here, minus 2x, then minus 3x. So this one will add up, and then you get a what? A 5x. No. Wow, that is weird. So you will get x, right? So I will put here a positive x. Then I can slide this one down. So that's minus 15. Then 5x squared, the first, divide by the first. So you will get 5. It's a positive. And then you multiply with this one here. So we shall get 5x squared, then minus 15. So when we subtract, there is a minus 15, then minus 15. So this one disappears, right? You get a 0. But then there is an x which is remaining. So that is an x. So meaning that the quotient, remember the quotient is the one that is up here. That is x plus 5. And then the remainder is equal to x, this one here. Part B, the variables x and y satisfy this differential equation. It is given that y is equal to 2 when x is equal to 2. Solve the differential equation to obtain an expression for y squared in terms of x. So the first thing we do is to separate variables. Okay, so separating variables, we need to put y's on one side and then x's on one side. So we do that using the cross multiplication. You are using multiplication and then division. So when I cross multiply, I'll bring this 6y here, then the dx this other side. So we shall have 6y, then dy, which is equal to x cubed plus 5x squared minus 2x, then minus 15, out of out of x squared minus 3, then dx. Do you realize that what we are having here is what they have told us to do in part A? That we divide this by this. So they can't give you something like this at first to divide, and then that there is no way you are going to use that in the next questions. So it is supposed to be applied. You see that? Now integrating on both sides, we shall get the integral of 6y with respect to y. Then this one is equal to the integral of this one. We got the quotient as x plus 5. Okay, then plus the remainder is x, then out of this x squared minus 3. So that is what we are going to have there. Remember, when you say like x over 2 is the same as 3, then plus a half, 3.5. You get it? This is the remainder. So the same thing we have done here. All right. Now integrating this one on the left hand side, increase the power by 1, that is 6y squared over 2. That will be 3y squared. And then here, this will be x squared over 2, then plus 5 x. Okay. And then next, you can see that when you differentiate this one, you get something that resembles what is up there. You see, when I differentiate this x squared minus 3, okay, I get 2x. Now, x, which is up there, okay, is a half of this 2x, not so? Is a half of the derivative of this x squared minus 3. Does it make sense? Okay, so this therefore implies, suppose I put this one down here, then I move this one here. So we shall have this one here, and then we say plus, now the integral of a half, this derivative of this one here is 2x. Are we there? Out of x squared minus 3 dx. And we know that when you integrate a function, you see that it is in the denominator, but what is in the numerator is the exact derivative of the denominator. then we get natural log of the denominator. You see that? So that one is very, very important. Okay, so meaning is that what we are going to have here, I will take this a half here, and then what will remain here is the 2x, which is the exact derivative of this. I've always said that, by the way, we don't need all of this in the exam that you are writing to show us. We don't want them. It is me who is just showing you where it is coming from, okay? Because I would have just written a half natural log of this, but where does it come from? So I've already said that differentiate the denominator. Then you ask yourself, which operation am I going to do on this one in order to get the what? The numerator there. So you will multiply this one by a half. Then that operation you have done on this derivative is what you are going to multiply through the natural log of the denominator. So I will say natural log of this x squared minus 3. Then I multiply it with this one here. You get that? Okay. So that therefore implies that we are going to have 3y squared, which is equal to x squared over 2, then plus 5 of x, then plus a half natural log of x squared minus 3. Then we can add an arbitrary constant. See, because whenever you differentiate a constant, it disappears. So since we are integrating, then which constant disappeared when they differentiated? Okay. So now we are supposed to find that c using these values given here. Remember, we have gotten 3y squared, which is equal to x squared over 2, then plus 5x, and then plus the natural log, a half of the natural log of x squared minus 3, then plus c. So we have x, which is equal to 2, and also y is equal to 2. So substituting here, we shall have 3, then 2 squared will be equal to 2 squared out of 2, then plus 5 times 2, then plus then a half of the natural log of 2 squared minus 3, then plus c. This one will be 4 minus 3, that is a 1. Natural log of a 1 is always 0, so this one vanishes. Then this one will be a 12, and 4 divided by 2, that will be a 2, then plus, this is a 10. Maybe just I can put this natural log of 1, but it is a 0. So meaning our c is going to be equal to, this is 12, okay? And then a 12, that's a 0. So 12 minus 12, that is a 0. So meaning this is the solution to our differential equation. So this one here is a general solution. Then this one here is a particular solution. Now they said that we obtain an expression for y squared in terms of x squared. In terms of x. So then what are we going to do? Very simple. Divide all through by what? By 3. So this y squared is going to be equal to the whole of this. Then we divide it by what? By 3. So we divide all through by 3. And then I can say y squared is going to be equal to x squared over 6, then plus 5x over 3, then plus, this is 1 over 6, then natural log of x squared minus 3 as our final answer. Question 11, part A, is coming from differentiation. The diagram shows the curve y is equal to cos x, then the square root of sine 2x for x ranging from 0 to pi over 2. The curve has the maximum point at m, where x is equal to a. Find the exact value of a. This is a turning point. Okay, turning point can be maximum or minimum. So we need to differentiate this one here. We have our y, which is equal to the cosine of x, and then sine 2x, then power half. So we are going to differentiate using the product rule. Okay, so dy dx here is going to be, we can keep this one constant, then we differentiate this sine 2x to the power of what? A half. Then after that, we can keep this sine 2x to the power of a half constant, and then we differentiate with respect to x this cosine of x. Here we are using product rule. Okay, so when we differentiate here, we shall drop the power. Okay, so that will be a half. Then sine 2x here, reduce it by 1. So you reduce this a half by 1, you'll get negative a half. Then times, now enter inside here and you differentiate. So when you differentiate sine, you'll get a cosine. Okay, but again, there is this 2x, you also enter inside here and you differentiate this. So there is a lot of chain rule applied here. So when you differentiate 2x, you get a 2, so I will multiply through that. And then plus, this is sine 2 of x to the power of a half, and then times, when you differentiate cosine, you get a negative sign. Okay, now for x which is equal to a, then dy dx is going to be equal to 0, because this one here is a maximum point, and for stationary points, dy dx is equal to 0. So wherever there is x, I'm going to put what? An a. Okay, so this will be 2 cosine of 2a. This is the one. Then there is cos of a, then divide by the square root. Because in indices, this one can go down. So the square root of sine 2x, but I'll write 2a. And by the way, this 2 here has disappeared. If you can see this and that, okay? Then minus sine of a, okay? Then times the square root of sine 2x. No, it has to be a, which is equal to what? To 0. Now everywhere, I'll multiply by root of sine 2a to eliminate the denominator. Okay, so here it goes. That means I will have cos 2a, cos a, then minus, here I will have sine a, then sine 2a, sine 2a, then is equal to 0. Or I can rewrite this and I say cos 2a cos a, then minus sine 2a sine a. Now, when you check in the list of formulae, you come here where there is trigonometry and look at this one here. I'm taking the minus because what I have the other side is a minus. So there is cos. How do I get a minus? The minus is up there. So it is cos of a plus b, which is equal to cos a cos b, then minus sine a sine b. Are we there? Sine b. For us, we are having cos of 2a cos a minus sine of 2a sine a. What do you think it is? Here they are saying you add the 2. Not so? So I'm going to get 2a, I add it to a. That means I will get cos of 2a plus a, which gives me cos of what? 3a. You see that? So we shall say from cos of a plus b, which is equal to cos of a sine of, no. Sorry. Cos of b, and then minus sine of a sine b Therefore, um, our A is this 2A, not so? Our B is the A. Therefore, this one here is going to be equal to cosine of 2A plus A, which will be equal to 0, and this will be cosine of 3A, which is equal to 0. So 3A will therefore be equal to the arc cos of 0, and for the arc cos of 0, we have 90 degrees. What are we given? We are given pi over 2. So, and this one, A is less than pi over 2. So this one is 90, which is pi over 2. Then there is also 270, which is 3 pi over 2. So when I divide all through, then A is going to be pi over 6, and then pi over 2 when you divide all through by 3. But then you can see that A is less than pi over 2. That means it is going to be pi over what? 6. You see that? Uh-huh. What did they tell us to find? The exact value of A. And that is the one, pi over 6. Part B, the region enclosed between the x-axis and the curve is rotated through 2 pi radians about the x-axis. Find the exact volume of the solid of revolution. Remember, if you have, maybe this is your curve, and you rotate it about x-axis, you are going to produce something like that. Okay, then we strip this one into very many small cylinders. So if we try to pull out a cylinder, okay, that cylinder there, we are having there is a difference in the x values here. So from here up to here is the height, which is actually the small change in the x values, right? Then from here up to here, that is the radius, not so? The radius. And when you look at this one here, it is a value of y, not so? It's a value of y. So meaning we shall have r, which is equal to y. Now volume of a cylinder is given by pi r squared h. The cross-sectional area, which is area of the circular part, then times the height. And this delta x is the height. So meaning your v here, we are rotating about x-axis. So our volume here is going to be equal to pi, then y squared, and then the delta x. You see that? But now, that is for one cylinder. So for many of them, we have to put all of those cylinders into one thing. That is what we call integration. To integrate is to put into one. So that is why for volume, we do what? We integrate. Okay? So keeping this one there, and maybe this one just up there. We check this one out. What do we have here? Okay, this one here, we are going to integrate. We have Vx is equal to the integral of pi, then y squared dx. Okay? From A to B. That is volume of solid of revolution, which you actually did in what? In pure math 1. So our volume here is now going to be, we are integrating from, they said the region enclosed between the x-axis and the curve. Okay, when we check here, the x-axis and the curve, that is from 0 to pi over 2. Not so? From 0 to pi over 2. Yeah. So I can put the pi actually outside because it is a constant. 0 to pi over 2. And then what do we have here? We have cosine of x and then the square root. So y is equal to cos x, and then the square root of sine what? 2x. That means y squared is going to be square here. That is cos squared of x, then times sine 2x. Okay, that is that. But also sine 2x, because now this one is going to be a product of two functions. Okay, but all of them are trigonometric functions, so we cannot use integration by parts, because we use integration by parts when we are having a product of two functions, but the functions have to be different. You get it? So here I have to simplify it. Sine 2x is the same as 2 sine x cos x, 2 sine x cos x. And then here we shall have 2, then cos cubed of x, and then sine of x. So this is what I'm going to write here. Cos 2 cos cubed x, then sine of x. Now with respect to what? To x. Now I'll let, here I'm going to use integration by substitution. So I'll let, since I can differentiate cosine and then I get a sine, then I can say let my u be equal to the cosine of x. So that means du dx is going to be equal to a negative what? Sine of x. So since I've changed the variable, that means even the dx has to be expressed in terms of u. So dx is therefore going to be negative du out of sine of x. Are we there? So meaning my volume here is going to be equal to, now the 2 pi is outside here, and then we integrate. And by the way, I think we need to also get the what? We need to get the limits. Okay, so let's change the limits. When x is equal to 0, then u is equal to cos of 0, which is actually 1. And then when x is equal to pi over 2, then u is equal to the cosine of pi over 2, which is 0. So implying that when we integrate this one here, where there is the x as a 0, I'm putting a 1. So that is 1. And then where this one was, I'm going to put a 0. Then this is cos cubed. Now cos cubed, cos is u, so I'll put u cubed here. And then times, here I'll have the sine x left, then times dx is here. So it is minus du, then out of sine of x. You see that? Then this one will disappear. Okay? And then we shall get our v of x, which is negative 2 pi, then the integral of 1, 0, then u cubed du. This is another thing that you should know. Okay? When you integrate a function with respect to x from a to b, okay, this one is the same as the negative of you integrating from b to a, okay, that function where b is greater than what? A. Very important. So this one here, I'll need this kind of reasoning here. Okay? Let me keep it there. I'll need this one here. So this simply implies that our v of x is going to be equal to, now the negative will be absorbed in here. Okay? So we shall have 2 pi, then the integral from 0 to 1, because you're supposed to integrate from the smaller unit to the upper unit. Okay, like that. Now we have 2 pi. Then here you have u to the power of 4 over 4. And then you put 1 and then the 0. So this will be 2 pi, then into 1 over 4, then minus, of course, 0. So that means this will be 2 pi over 4, which is actually pi over 2. And that will be our exact answer. And I think they told us to give the exact, so find the exact volume. The answer is pi over 2. So this has been it for the second part of the paper. Thank you so much for watching. May God bless you. If you find the content very helpful, kindly like, share, and even subscribe. See you in the next videos.